Hey everyone, welcome back to the College Algebra playlist. In the previous videos, we took a look at linear and quadratic equations. Alright, so now we're ready to move on to a new type of equation. Alright, in this playlist, I want to take a look at rational, radical, and absolute value equations, as well as a few other types. Alright, so let's get started with rational equations right now. Okay, here we go. Rational equations. The first thing we need to do is define what a rational expression is. All right, a rational expression is simply the quotient of two polynomials. All right, so down here, the black fraction, the blue fraction, and the red fraction and the green fraction all represent rational expressions. All right, they're all examples of rational expressions. And notice that in the numerator, we can have stuff involving variables, or we can just have constants, right? When they have constants, right, that's just a really simple example of a polynomial. All right, but the key is that variables appear in the denominators. All right, that's what really matters. For something to be a rational expression, it's got to have variables in the denominators. All right, so that leads us into the definition of a rational equation. All right, let's define that right now. A rational equation contains at least one rational expression where the variable appears in at least one of the denominators. All right, so here we have an example of a rational equation. All right, it's made up of rational expressions, and we do have a variable appearing in at least one denominator, right? So this is an example, and notice the restriction over here on the right. X cannot equal 0, okay, because if you plug in 0 here for x, you'll get division by 0, all right, and we can't divide by 0 in algebra, all right? So let's talk about how to solve this thing, all right? There are two strategies that I want to cover in this video, all right? The first strategy is to eliminate all denominators by multiplying both sides of the equation by the least common denominator, okay, by the LCD. All right, if you need a refresher on the LCD, go check out the 19th video in this playlist. All right, I'll include a link in the description. All right, so for strategy number one, we're going to multiply both sides of the equation by the LCD to get rid of the fractions. All right, the result is that we get an equation that we know how to solve. All right, it'll result in a linear or a quadratic equation or something else. All right, something we know how to solve. And then the last step is to solve, then check the solution. All right, it turns out that checking the solution is really important for radical equations and rational equations. All right, we'll talk more about that later. For now, let's actually try to solve this thing. All right, let's multiply both sides by the LCD. So the LCD is the least common multiple of the denominators. All right, we have 2x, 3x, and 3. All right, the least common multiple of those three things is 6x. All right, so we're going to multiply both sides by that. All right, let's take this to the top of the screen. Okay. And on the left-hand side, what we have is a distribution situation, right? We're going to use the distributive property to get rid of the parentheses here. All right, and then on the right-hand side, we just have a simple multiplication. All right, so when we distribute, this is what we get. All right, we get 6x times this plus 6x times this equals this product over here. All right, so a lot of stuff is going to reduce and cancel. All right, 6 over 2, that's 3 over 1, okay? And then in blue, right, these x's cancel with each other, okay? And then 6 over 3, right, that reduces to 2 over 1, and the x's cancel. All right, and then over here, 6 over 3, that's 2 over 1, okay? So what we get is a linear equation that we know how to solve. All right, we have 3 times 7 plus 2 times negative 5 equals 22 times 2x. Okay, so the fractions are gone. All right, we got rid of the denominators. All right, so we know how to solve this linear equation. Let's take it to the top of the screen and let's get to work. All right, on the left-hand side, I have 21 plus negative 10. All right, and then on the right, I have 22 times 2x, which is 44x. All right. On the left-hand side, I have 11. All right, so we're isolating x on the right-hand side of the equation. All right, that feels a little goofy. All right, we usually isolate on the left-hand side, but we can do this if we want to. It's perfectly valid. All right, so now we can divide both sides by 44. All right, and the 44s cancel. And that gives us x equals 11 over 44, which reduces to 1 over 4. All right? So before I put a box around this and declare it to be my solution, I need to check it. All right? It's crucial in rational equations to check your answers. All right? What do I mean by that? Let's take the potential solution x equals 1/4 and plug it in everywhere we see x. All right? We want to see if this satisfies the equation. All right? Does it make it true? All right, we plug in the value. We want to know if we end up with a true equation. All right, let's find out. So I plug in x here. All right, I get 7 over 2 times 1/4 minus 5 over 3 times 1/4 equals 22 over 3. All right, the question is, does the left-hand side match the right-hand side? All right. So down here, right, I get 2 over 4, which is 1/2, and then 3 times 1/4 is 3/4. All right. So what I'm going to do next is multiply 7 by the reciprocal of 1/2. All right. So multiply it by 2 over 1. And I'm going to multiply 5 by the reciprocal of 3/4. All right. So we're almost there. All right, let's take this result to the top of the screen. And we get 14 over 1 minus 20 over 3 on the left-hand side. All right. And we get a common denominator by multiplying this thing by 3 over 3. All right. That gives us 42 over 3 minus 20 over 3. And on the left-hand side, that's 22 over 3. So it does match the right-hand side, right? It does give us a true equation. All right. So we can declare that x equals 1/4 is a valid solution. All right. So that's strategy number 1. Multiply both sides of the rational equation by the LCD to get rid of the fractions, and then solve the resulting equation. All right, and then check your answer. Strategy number 2 is to get one fraction on the left-hand side and one fraction on the right-hand side. All right. Then we use cross multiplication to write down a new equation that we know how to solve. All right, linear, quadratic, etc. All right, then we solve and check the solution. All right. So there's a property in algebra that we haven't talked about before. All right. Cross multiplication. What does that mean? It means if you have a fraction equal to one fraction, right? If you have one fraction on both sides, you can take the product AD and set it equal to the product BC. All right? That's cross multiplication. All right? So strategy number 2 is to get something that looks like this so that you can use cross multiplication. All right, you just get one fraction on the right-hand side and one fraction on the left-hand side, and then you do this. All right, so let's try that with this example we looked at earlier. All right, our goal is to get one fraction on the left-hand side. How do we do that? We do that by making this subtraction happen. All right, we get a common denominator and subtract these fractions, right? We condense two fractions into one. All right, that's what happens when we add or subtract fractions. Okay, so let's multiply 7 over 2x by 3 over 3 and multiply 5 over 3x times 2 over 2. All right, the common denominator we're looking for is 6x. All right, so we get 21 over 6x minus 10 over 6x. All right, so we can condense the two fractions into one right here. All right. And then we just perform the subtraction in the numerator, right? That gives us 11 up top. Okay, so we have 11 over 6x equals 22 over 3. All right? At this point, we can use cross multiplication, right? We can set the product 11 times 3 equal to the product 6x times 22. Okay? So simplifying a bit, we get 33 equals 132x. All right, let's take this to the top of the screen. All right? And then we divide both sides by 132 to isolate x on the right-hand side. All right, the 132's cancel, and that gives us x equals 33 over 132. All right, if you plug that into your calculator, you'll get 0.25. All right, so this thing reduces to 1/4. All right, that's the same solution we got from strategy number 1. All right, and we already checked this value, right? We put 1/4 in for x everywhere. And then once the dust settled, right, we saw that we had a true equation. All right, so 1/4 satisfies the equation. Strategies number 1 and number 2 gave us the same solution, and we already checked that that solution satisfies the original equation. All right? But what if it doesn't? That's the question I want to ask next. What if the solution we get is invalid? What does that look like? An invalid solution is called extraneous, all right? An extraneous solution is a value that appears to solve an equation after performing algebraic steps, but does not actually satisfy the original equation, all right? Extraneous solutions can occur when we solve rational and radical equations, all right? So I always used to tell my students, right, if it starts with ra, beware, right? Just be cautious of extraneous solutions, all right? If it starts with ra, you need to check your solutions, all right, to make sure that they satisfy the original equations, all right? Extraneous solutions can also occur in some other types of equations, but these are the main two that we're going to look at, all right? Rational and radical equations, all right? So here's an example where we get an extraneous solution, all right? I'm going to use strategy number 1 to solve this thing, all right? I'm going to multiply both sides by the LCD, right, which is x minus 2 in this case, all right? So let's see what we get when we multiply over here and then when we distribute over here, right? We're distributing from the right, all right? That gives us this, all right? And a bunch of stuff cancels, right? We can see that some stuff cancels here. The x minus 2's go away over here, and the x minus 2's go away over here, all right? That leaves us with a linear equation that we know how to solve, all right? That's strategy number 1. Okay, let's take this result to the top of the screen. I have x equals 2 plus 2 times x minus 2, all right? When I distribute this 2, right, I get 2x minus 4, okay? And then when I subtract 2 minus 4, I get negative 2, all right? And then I'm going to subtract 2x from both sides, all right? I want to get everything with x on the left-hand side, all right? And that's going to give me 1x minus 2x, right, which is negative 1x, all right? I get negative x equals negative 2, okay? And when I divide both sides by negative 1, I get x equals 2, all right? So before we box this, right, before we put a box around it and declare it to be our solution, we need to check it. All right, we need to check this value in the original equation. All right, here's the original equation, all right, and it comes with a restriction, right? I can't have x equals 2, all right, because if I plug a 2 in here, I get 2 minus 2, which is 0. All right, I get division by 0, which is not allowed in algebra, all right? So instead of plugging this value in to the original equation to see if you get something satisfied, we're just going to compare our solution to the restrictions in the original problem, all right? That's sort of the lazy way to check your answer, all right? You can just compare it to the list of restricted values, all right? But the best way to check your solutions is to plug them into the original equation, all right? That tells you for sure if it's valid or not, all right? But here, for the sake of brevity, we'll just compare, right? And we'll say x equals 2 is an extraneous solution because of this restriction here, right? We can't have x equals 2. So this equation has no solution. All right? So why do extraneous solutions occur? That's the question I want to ask next. All right? We're creating a new equation, linear, quadratic, etc., that has more solutions than the original. Okay, so when we use strategy number 1 or strategy number 2, right, we get rid of the fractions and we end up with something linear or quadratic or whatever. All right, something we know how to solve. All right? When that happens, that new equation basically forgets about the restrictions in the original problem. And the algebra gives us all possible candidates for solutions. But some of those candidates were never valid to begin with. All right? So solving gives us potential solutions, and checking gives us actual solutions. All right, so that's why it's super important to check your solutions when you're working on rational or radical equations. All right. Let's try one more example. All right, and let's compare the solution we get to this restriction right here to see if the solution is extraneous. All right, I'm going to use strategy number 1 here. All right, I'm going to multiply both sides by the LCD, which is 2 times x minus 2. All right. So we're going to distribute from the right again and make this multiplication happen on the left-hand side. All right, and that gives us this. Okay. So some stuff is going to cancel here, right? The x minus 2's go away over here, and they go away over here as well, and then this 2 cancels with this 2. All right, that gives us a linear equation, 2x equals 5 times 2 minus x minus 2. All right, let's take this to the top of the screen. And we get 2x equals 10 minus x minus a negative 2, so plus 2. All right. 10 plus 2 is 12. Okay, so we have that on the right-hand side. Now let's add x to both sides. And we get 3x equals 12. All right. So next, let's divide both sides by 3. And the 3's cancel on the left-hand side. And that gives us x equals 4. All right. So this is a rational equation, right? So we need to check this answer. All right. So we compare x equals 4 to the list of excluded values. All right, we compare it to that restriction, right? It said x cannot equal 2. All right, we got 4. All right, so that means that x equals 4 is a valid solution. All right. Be sure to ask your instructor how they want you to check your solutions, right? Some of them might be okay with you comparing this solution to the restrictions, and other instructors might want you to plug the value into the original equation and see if it's satisfied. All right. That does it for this video. Thank you for watching, and like and subscribe.